Hi class, let's take a look at example 2. Now in example 2, one of the main premises that we have is that we're assuming that it's not bell shape. So if we're talking about unusual scores in the actual data set, we're told that it's not bell shape or not likely to bell shape, then this is the proper interval that we're considering. So we could still consider this one if they mention that it's approximately bell shape, but in any situation where they're actually stating it's not bell shape, the main idea behind it is that we don't know what the distribution could look like, and it could be any distributions that you can think of. So it could be the ones that we've talked about. There's actually more, but in this specific scenario, we're going to be calculating the interval in this format. So we're going to be doing the lower and upper fence, and then basically carry this calculation. The IQR comes into place here. So as we're looking at unusual scores, we're still looking at values that happen to be in the extremes. In this case, these will be your maximums and these will be your minimum values. So same idea, except that we may not know in this particular scenario what the distribution looks like. So we're looking at an interval that is adjusted for mostly all of them. Okay, so the first question is also asking in here, do you see any possible outliers? So in this case, we're going to say 5, and technically that's your min, and that would be your max. So those are the only possible ones that we could consider. You do have 295, so 95 could be omitted, but then if we're going to omit a 95, you have to calculate the unusual scores or justify why you're not considering it. So for possible outliers, it's just easier to consider both of those. And let me write it as the possible outliers are technically 5 and 95. You can say both 5 and 95 are far from the rest. Whoops, it's supposed to say scores. Okay, so that takes care of part A. Now, they want us to find, in this case, in B, unusual scores. So we have to calculate the usual interval. Now, for the usual interval, we're actually going to have to calculate the values of Q1 and Q3. So let's actually take a second and enter these into the calculator. You can put them under list 1. And if you want to pause the video, that's perfectly fine. Double check that you have all the values. In this case, I entered them before the video. And then check if you're matching to my calculations. So for this one, we're having that the Q1 is 65. In this case, this is 65. And our Q3 is 94. Now, the first calculation that we need is the IQR. And this is going to be Q3 minus Q1. So 94 minus 65, which is going to give us a 29. Let me double check that. 94 minus 65, that's 29. And then let me just go back to the formulas. So that's the formula that we're evaluating. Now we need to evaluate the lower and the upper fence. So for this one, the lower fence is equal to 65 minus 1.5 times the IQR. So it's equal to 65 minus 1.5 times 29. The upper fence is equal to 94 plus 1.5 times the IQR. So this is equal to 94 plus 1.5 times 29. Let me punch it in so we can compare answers. So the lower bound, I'm getting 21.5. the upper bound I'm getting 137.5. So usual interval, it's going to be equal to 21.5 to 137.5. You can round it to the nearest integer because your data set is all integer values. So you could say that it's going to be 22 to 138, and the units happen to be hours. So this is the usual interval. Since we don't know what the distribution looks like on this one, this is supposed to say hours. Sorry, you guys, I'm at an angle here. And those are the ones that we're supposed to be seeing. At this point, you go back and look at the possible outliers and you see if any value it's actually not in this interval, and the only one that I see, it's the 5. So you would write it out in this format. So the only unusual score is technically 5 hours, since it is outside of the usual interval of, and in this case our usual interval ended up being 22 to 138, and then the units on this one is hours. So as we're looking at graphs of this distribution, we should see that most of the actual values for values that we're expecting to belong to the distribution are within 22 to 138. Any value that's on the outside, it's too far from the rest, and technically will be considered an outlier. In this case, we're just mentioning them as unusual scores because we don't have other evidence in terms of if we already have all values of the population, or if we continue to collect data and the population keeps growing and growing. So in this case, that would be it for this one. Here's an example of a scenario where we're considering the actual data set not be bell shape, and we're still looking at any unusual scores or possible outliers. So the answer for possible outliers stays the same. The unusual score, we need technically a little bit of calculations to come up with that interval, and any value outside, in this case of, well, the lower and upper fence, would be considered an outlier. We're just keeping it as unusual score because, like I said, we don't know if we already have all values of the population. So that's actually it for this one.